Hi guys, today we are going to start exercise 1.6 that is about simultaneous linear equation. Equation mean the statements which have the sign of equality. We are going to solve these equation by using inversion method here. There are the two methods to solve these. First method is the inversion method that we'll use today to solve these equations. So the technique which we are going to use here to solve these equations is the matrices. So first of all, we write these equations in the form of matrices. First, I will write this in the matrix form. This is 2. The coefficient of x is here 3. The coefficient means the number that is written with the variable. Here the coefficient of y is -2. Here the coefficient of y is 2. The variables are here x and y. And this is equals to 4 and this is equals to 6. Now we'll give the names to these matrices. The names to these matrices are, first this matrix is called matrix A. This is called matrix X, that is consists of the value of x and y. And this is called matrix B. Here we'll have to find this one x, because we need this the value of x and y. A on the other side will be A inverse and into B. Mean if we multiply the inverse of A with B, we can get the value of x over here. But we cannot find the inverse of all the values in the universe, all the matrices in the universe. First we'll have to check that the matrix is A is a singular or non-singular. That we will check by taking its determinant. Determinant of A, determinant of 2, -2, 3 and 2. How we can find the determinant? By multiplying the diagonals and off diagonal entries with the sign of minus. 2 times, that is 4. So directly I am going to do 2 into 2 minus 3 into -2. 2 times 4 minus plus 3 2 times 6 equals to 10, and this is not equal to 0. Mean this is a non-singular matrix. We can solve this. So we'll continue from here. X equals to A inverse, mean the formula of A inverse is adjoint of A over determinant of A into matrix B. So here I will put the values. X equals to adjoint of A. The matrix A is here 2, -2, 3, 2. The determinant of this matrix A is equals to 10. The matrix B is here 4 and 6 in the form of column. In the next step, we will take the adjoint of this matrix, and adjoint means we will interchange the diagonal entries and change the sign of non-diagonal entries. So here this is interchange the diagonal entries. 2 will be interchanged by 2. -2 will be +2. +3 will be -3. Matrix B is 4, 6, and this is divided by 10. Now we multiply both these matrices in the same way. Rows will be multiplied by the columns. So the first row will be multiplied by the column. 2 multiplied by 4 plus 2 multiplied by 6. Then -3 multiplied by 4 plus 2 multiplied by 6. And this is divided by 10. 2 4 times 8. 2 6 times 12. minus 3 4 times 12 plus 6 2 times 12 divided by 10. 12 plus 8, that is equals to 20. And here minus 12 plus 12 equals to 0. And this is divided by 10. It means now both the entries 20 and 0, they will be divided by 10. 20 divided by 10, 0 divided by 10 equals to 10. 2 times 20, 0 by 10 equals to 0. So x we can write over here now. This is x is equals to xy, because in the start we have put in place of xy this x, and now x we can written again as xy. Here x equals to 2, y is equals to 0, because the value of x is 2 and the value of y is 0. We have to find here the values of x and y, because these are the variables involved in these equations. Because now the part 4 we will solve here, because all the parts are same, the method is same, only the values are different. So you will use here the same rule to solve this. We'll use here the inversion method again. Inversion method, first of all, we'll have to write these equations in the form of matrix. 3. Here the variable of x is, coefficient of x is 5. Here the coefficient of y is minus 2. Take care of the signs here. Here the variables, coefficient of the variable y is minus 2. We will take care of the plus minus here. X, y are the variables, and this is equals to minus 6, and this equation is equals to minus 10. Now we are going to give the names to these matrices. This is called matrix A, this is called X equals to, this is called matrix B. We'll have to find here the value of this matrix X, that will be right here. A on the other side will be A inverse into B. Means we will multiply the inverse of A by B. But first we'll have to check, and we find the inverse up here. So for this purpose we'll have to check the matrix is singular or non-singular. We'll take the determinant of this. 3 minus 2, 5 minus 2. I will find 3 2 times. 3 into minus 2 with the sign of minus of diagonal entries. 5 into minus 2. This is minus 6, minus minus plus, 5 2 times 10. Plus 10 minus 6 is 4, that is not equal to 0. Mean this is a non-singular matrix, we can find its inverse. So we'll continue from here. X equals to, the formula of A inverse is adjoint of A over determinant of A into B. So first of all, I will take here the adjoint of A. Adjoint of matrix A, I will write over here. That is 3 minus 2, 5 minus 2. Matrix B is here, minus 6, minus 10. And the determinant we have found already here, that is 4. Now I will find the adjoint of these matrices. For finding the adjoint, we will have to interchange the diagonal entries and change the sign of all diagonal entries. Here the diagonal entries are 3 minus 2. We will interchange them, mean we will change the place. Here is minus 2. Here there is 3. Minus 2 will be here, that is plus 2. And plus 5 is here, that is minus 5. This is now minus 6, minus 10, and this is divided by 4. Now we are going to multiply these two matrices. The rows will be multiplied by the columns of this matrix. So minus 2 plus 2 is the first row will be multiplied by this column. Minus 2 into minus 6 plus 2 into minus 10. Second row minus 5 into minus 6 plus 3 into minus 10. And this is divided by 4. This is equals to minus minus plus 6 2 times 12 plus minus minus 10 2 times 20 minus minus plus 6 5 times 30 minus 3 10 times 30, and this is divided by 4. Now you can see from here 12 minus 20, that is equals to minus 8. Minus 8 plus 30 minus 30 is 0. Minus 8, this is 0. They both are divided by 4. Here minus 8 divided by 4, 0 divided by 4. 4 2 times 8 minus 2. 0 divided by 4 is equals to 0. So here the value of x, y equals to minus 2 and 0. The value of x is here minus 2. The value of y is here 0. So this is the way how to use the inversion method to solve the simultaneous linear equation. Thank you.